Okay, I think. So we are live now. Uh, Hello everyone. We welcome together Cagatay and Vinci, who
We are live now.
okay. We welcome Vinci and Cagatay, who are Flutter developers. So Cagatay mainly is an Android developer and Flutter developer at Wolt, which is based in Finland, and Vinci is a software engineer and mainly Flutter developer in MediaMarktSaturn, which is based in both Germany and Spain. Okay, so we will start with Karatai, who will go deeply into Flutter, will introduce to us how it works under the hood, and uh, introduce the three trees of Flutter and go deeply with it. So, hello, Karatai.
Hello. I usually don't correct people, but actually my name is Çağatay, and I'm not blaming anyone. Like it's really difficult to say. It's a Turkish name. I'm from Turkey. I've been living in Finland for around 11 years, but I'm so used to. And even when I'm introducing myself, sometimes when I'm in the grocery stores or like some uh, document works, I just say Cagatay, but
Karatai.
Çağatay.
Okay, so Chatai.
Yes, very good.
Good. Okay, so we will start with you. Uh,
Perfect.
yes.
Shall I share my screen right now, or do we have some other things to talk?
Okay. If you want to introduce yourself and
Okay.
Vinci, then we
Yes.
can start with you.
Yes. Okay. But before that, I'm very happy to be here with Vince also because um, I'm a runner. Because of Corona, I lost my motivation. I'm not going out that much. But whenever I go for running, I always listen to podcasts. And this sound coming from Vince, it's very familiar to me. And it has a relaxing tone, actually.
Thank you.
It's so nice
Yeah.
to be here with you, Vince. And yeah, I'm Çağatay. I'm from Turkey, and I've been living in here for 11 years. I'm a telecommunications engineer, but I'm kind of a person who likes to develop apps that is directly going to end users instead of working in the lower layers of telecommunications. So I like working with user interfaces, and Flutter just for me because you develop really fast, very fast applications. You get the results fast, but at the same time, it is a bit also problematic because when you develop things fast, you stop sitting back and trying to understand what is actually going on. So that's why in this talk, we are going to deep dive because I've been doing Flutter for 1.5 years without knowing these really details that I'm going to talk now. The reason why I studied these things and I want to share these things because I was able to do what designers asked me, but then when there are some how can I say like different things, let's say like special components needs to be built. We really need to understand how the framework works, and this is why we are deep diving so that we can understand the framework and then build special things with Flutter, not just like traditional UIs or yeah.
Good, awesome. So we will go deeply with you. We will go deeper with you, and then we will go with null safety with Vinci.
Perfect. Yeah. Just one thing I wanted to mention with the podcast that basically I'm also a runner, and it's exactly I was listening to the It's All Widget podcast, and I'm like when I run, I'm always listening to other podcasts, and I was so sad when there was no new episode from the It's All Widgets podcast, and that's why that was kind of the motivation for me to create the podcast to just basically I know that most often a book or a video is maybe better because then you can share the code and everything, but my use case was exactly like yours, that when I'm running, I like to listen to tech podcasts, and it's good to hear that you listen to it.
Yeah, I think I listened every single episode.
Wow, then I need to catch up and start releasing episodes again.
Yeah, actually, I don't know how it is going, but there is not many coming as before.
Yeah. Let's see. Hopefully, I can crunch
Looking
out
forward.
and pump out more episodes soon. Yeah.
Okay.
So I can introduce too that I'm also a runner, and yes, we are three runners here, and I usually listen to music when I run, and now it's shortly I started listening to podcasts when I drive and when I run. So
Yeah.
I started with Vince's podcast. Is yes, he did it with all the Flutter GDEs and the company owners. So he did all. Also, once from the Flutter team, you have
Yeah.
in the podcast.
Yeah, I had a couple of people from the Flutter team. Yeah.
Yes, so it's awesome. Okay, so we can start with the first presentation and with the first speaker, Chartai,
Yes. Before
right?
that, just a second. Oh, I know my laptop was just broken, and I got new Mac M1, and I
Mhm.
just got it yesterday. I just need to give permission and need to restart the Chrome. Sorry about that. I will be 1-2 minutes away. Really, this shouldn't have happened, but yeah, I will be
No,
back.
no.
I'm just
Okay,
giving permission and restarting Chrome.
take your time. So it happens with the MacBook.
Yeah. Yeah. Oh, um, I might have a question. Do we have a YouTube feed somewhere, or I'm not 100% sure where I can find, for example, the comments, if there are any.
Yes,
Oh,
we have the bar in the right, the sidebar in the
okay.
right. We have comments. It's YouTube comments, and we have
Okay.
yes, and we have private chat. It's for the private chat.
Okay. Thank you very much. Yeah, it's good to hear that people listen to the podcast, and I try to release more episodes, and let's see if we can present or listen to the.
Am I back?
And also, yep.
Okay, perfect. Now I'm setting up everything again. Sorry. Yeah.
Good. So for Vinci, I can share your podcast with the people who are listening and watching now, so they can
Thank you.
listen to your podcast and give us some feedbacks.
Yeah, thank you.
Okay, and I am ready.
Okay, so we will start with you.
Yes, just a second. I will also set one more thing and then I'm back. Okay, now I can start. Hello again, welcome. As I explained, today's talk is about Flutter deep dive. Why? Because Flutter is it's complicated when you go deep dive, when you do a deep dive. Otherwise, Flutter is really simple. When you want to learn Flutter, like it doesn't take much time. I was an Android developer for 7 years, and I started a new job as a Flutter developer with zero experience. And in a month, I was able to catch up and understand all the concepts because, as I said, it is pretty easy when you are working with the widgets. But when you want to do special things, then, as I said, you need to dive deeper and try to understand the concepts. In this talk, we will start with widgets and then continue with the elements, build context, stateful widget, render object, rendering pipeline. So many things about Flutter that we don't probably use in our daily work when we are working with Flutter, because we work with widgets, we do composition, and then build a widget tree, give this widget tree to the framework. Framework takes care about the rest. That's care about the rest, yeah. So let's continue. How deep we will go? I would say that I'm not really expert here to tell everything about Flutter, but we will go deep enough to build that special thing. And what is that special thing? It is the component, UI component, that I have been working on for months to be able to implement it in our project at Wolt. So this component is multi-page scrollable bottom sheet. In Flutter Global Summit in December 8th, we had an introduction talk with my colleagues at Wolt, Scott, product designer, Maria, motion designer, and me as a Flutter developer. So I got the design of the demo project from Scott and the motion specs from Masha, and created this demo project in GitHub. It is now available in my GitHub. You can access it with this Ulusoy handle. And yes, we had this introduction in Global Summit, and now we are going to talk about the technical background to have just enough technical background to implement this bottom sheet. And then on February 3, I'm going to talk about the motion specs, mainly motion specs, and I'm going to use flow widgets, and I'm going to talk about staggered animations, and we will implement these motion specs that Masha provides me. So it's kind of how to receive the specs from motion designer and deliver code to the product owner. Yes, and then finally, to be not decided yet, but soon after the conference, I will share a series of articles. I'm kind of a person who learns by writing Medium articles. I have until now, I have 3 series. One is about theming in Flutter with provider, and then Navigator 2 article series, and finally building a single page scrollable website with Flutter. And the last one will be multi-page scrollable bottom sheet. Yeah, we talked a lot about this multi-page, but so what is this multi-page that I'm talking about? I want to just quickly show you what I'm talking about. I'm going to share my phone. So, okay, let's try. Okay, now it's there. So you are seeing my phone screen now. And so this is a demo app. And then when I press this one, it will show the bottom sheet. And let's see, I choose this one, this meme. And then it takes me to the other page. And I write something, hello world. And then I accept it, generate it. So it goes to the 3rd page, but of course I can go back to the first pages. So let's choose this one, and then save. So you see that this is a smooth experience. Let's see how it is actually, what is going on behind in these milliseconds. To do that, I have on the top right this animation scale. So now it's going to be slower. The animations will be slower. Let's see. Now my bottom sheet is coming. So let's pick a meme. So you see that the change of the page is very smooth. And there is a motion that eases the cognition, meaning that by just looking, it helps me to understand that I am navigating to the next page. And I press this. The motion tells me that it is navigating back. So this is kind of this motion specs helps you to understand where you are with the app to your mind. And let's continue. But by the way, one more thing about this scroll animation. So when you go down, you see that the top bar will dismiss, and then it will be visible again. So this kind of motions that I'm talking about. Let's continue. Let's choose this one. So it's like reading a book or having a notebook and then going to the next page of the notebook. So you press this. Let me write something here quick. Yep. Okay. So now let's see. So think it about like I'm going to the next page, like going to the other page when reading a book. Yes, and then going back. So the content goes from left to right or right to left, depending on the navigation direction. And then there is, as I said, this motion animation when scrolling in the page. But like this scrollable bottom sheet looks really, I'm going to give you one more example. So this scrollable bottom sheets or multi-page bottom sheets, it is really useful in the app for user experience, but when it is not really carefully done, it is really making difficult to navigate in this bottom sheet. I'm going to give one example. This is from one of my favorite apps, Strava. So let's see. Now, see, when you in the Strava also has this bottom sheet concept with multi-page. So this is really like when not done, the motion of this is not done well, it makes it really difficult to understand where you are. So what is going on now, where I am, and now how can I go back? So I think I will press this one, yes, but it didn't close the bottom sheet. And now here. So in the end, what I want to say is that this bottom sheet is really useful component in the apps, but the motion animation, the motion specs that we use are also equally important, because otherwise you are lost and it makes it difficult to navigate it when using the app. Yes, this was about it. And let's continue. Part one, we will first talk about the three trees of Flutter, because this three trees of Flutter is a very famous talk. If you check YouTube, there's a really nice talk by Andre Fitzgibbon and Matt Sullivan. I would strongly suggest to check that talk, and I also have some inspiration from this talk while explaining this concept. But what is this mahogany staircase? Let's read it. Mahogany staircase refers to the Flutter framework design, where a tree of representative objects used to construct parallel tree that describes original objects in a new way. We will see here now what it means. We have a widget tree, it's one tree. And then, let's read it again. There will be another tree of representative objects, which is element tree. And then there is another tree, render tree. They all have their own responsibilities. Let's start with widget now. So what is widget? I don't know if you have Android background. I have Android background, and we developed UI using XMLs. Now there is luckily Jetpack Compose, but it is not really commonly used. Hopefully the future of Android UI development will be Jetpack Compose, which looks very similar to Flutter. But anyway, before Jetpack Compose, we were using XML, right? XML, what is XML? XML is a markup language. And Flutter actually uses Dart code as a markup language. And then widget is not different than describing what should be in the UI by providing, attributes. So it is not that different. But instead of this XML, we have Dart code. And widget is just a configuration. What we do with widgets, we tell the framework what we want to see in a portion of UI. And we describe what we want to see. The most important thing about widgets is that they are immutable. So if you're an Android developer again, you have your view, and then you can update the properties of the view, but widget is not like that. Widget is immutable. Once you create a widget, it has its own attributes, but you can change these attributes. Widget.color equals black now. We can say that. And then there is element. What is element? For every widget, in the widget tree, there is a corresponding element in the element tree. An element is information hub. I will describe it like that because widgets, they just have the description. It's just a configuration. But these elements know many things about widgets. It knows the parent of the widget, children of the widget, size, the render object of the widget, which will come next. It holds references. It's like the central point, hub. What it does, it makes sure everything plays well together. And when we are developing, we always work with widgets, right? Not always, but we usually work with widgets. And then with this build method, the framework provides us build context. So this build context is actually an element. And surprisingly, when I ask developers, like, have you heard element? No. But have you heard build context? Yes. Because you get the size, for example, context.size. But in the app, when developing, you don't say element.size. Build context is just an interface that element implements. Why we have build context but not elements? Because it discourages us direct manipulation. This is the quote from the documentation. Why we have build context? Because the framework doesn't want us to use all the public or doesn't want us to mess up with elements. Just use the build context. These are the exposed methods you can use. When you are calling a method on the build context, actually you are calling this method on element. And then we have render tree. Render tree has render objects, which does the heavy work, like laying out, positioning, painting, hit testing, semantics, like accessibility. All the hard work is done in the render objects. And element has references to both render objects and the widgets. So let's sum up. Just a second. I'm checking my notes. Yes, let's sum up. Widget tree maintained by app developers and only hold the configuration data, description. Element tree is the logical structure. It is reconstructed by widget tree when we call the build method, and then knows about the location of the widgets in the tree. And then we have the render tree, which is geometrical structure, and geometry is computed during the layout phase and used in the painting phase. This is all about what I want to say about these three trees, but as I said, I would suggest watching this 26 minutes talk on YouTube from these guys. It is really amazing. And then optimization. This is the most important thing. And this is about now deep diving. So what we said is that we provide widget tree to the framework, and then elements is the information hub. It has access to render object, and then it updates the render object. Whenever we have a build in the build phase, we actually provide new widget tree, right? We can't update the widgets. So if we want to change a portion of the UI, how do we do it? We provide a new widget tree. So imagine you have an animation, and then in the milliseconds level, you have many consecutive builds. So you provide widget trees in every, in 1 second, multiple times. And think about this. I thought at first this should be really difficult work, and it should be from performance point, it should be difficult for Flutter, especially these animations. But Flutter provides, Flutter is capable of 60 frames per second up to 120 frame per second animation, frame per second support, the performance. So Flutter is capable of this, but how it is capable of this? Although we provide a new widget tree when we change the UI at milliseconds level, the element tree and the widget tree, they are not all the time created. Flutter framework tries to reuse these elements and the render trees, the renders objects, as much as possible. And then there is this method, element.updateChild. This is the core of the widget system. It is called whenever we add, remove, or update child based on the widgets. So what does this update child method takes? It takes the child element, the new widget in the build, and then this new slot that we are not going to talk about now because we want to focus on this optimization. Okay, so this is the summary of how this optimization works, and I find it really, really important. And as said in the documentation, this is the core of the widget system. This is the core of the optimization. Let's start now. So when we have a build, the build happens from top to down. The widget is inflated, element is created, and the element examines each child. Each element can have, for example, a column widget has multiple children, right? For element, it also has the corresponding children. So an element also has multiple children. And how does this optimization happen? The parent element examines each child one by one, and then it decides whether reuse, remove, or update the child. Let's start with case by case. Let's focus on the first case, case 1. What is happening here? I just got this from the source code. In the first case, the new widget is null, and then child is not null, and deactivated child, and then null is returned. This is the first case, meaning that there was an element, but then in the next build, the widget, there is no widget in that location. So we don't need to have that. We don't need to keep the element. We need to deactivate the element. This is interesting because it is not actually removing the element from the element tree. Instead, it is making it inactive. Why? Because elements still can be reused during the build phase using global keys. This is called a tree surgery. But just to understand this one, once we are deactivating a child, we are still waiting the end of the build because there is still a possibility that with the global keys, the element can be reused. Anyway, after the build phase, if framework realizes that this element is not used at all, then the resources are freed, the element is demounted. Okay, let's continue. Now, in this case, the child is not null. We have this element, but let's see. The old widget for that element, I mean, from the previous frame, we compare first if they have the the framework compares if they have the same superclass, and then the old widget is exactly the same as the new widget. This exactly same is not actually this correct meaning, but they have the same reference. So are they really the same widgets? And if this is the case, we are not updating anything. We are exactly reusing the same element. The framework thinks that this is the same element. And this is really, from performance point, this is really where we want to be. This is why we have the const. We prefer the const widgets. We prefer const constructors. Because the reference for the const constructors, the reference is known in the compile time, and the framework knows that it's exactly the same widget in every build. So it doesn't call build for that element. This is here, new widget equals the child widget. They have the same references. As I said, this is where we want to be. To be in the same in this place, we can also use cached widgets. We can have a widget list, and we can reuse them in the same widgets. In the next build. But the best way is using the const constructors, widgets with const constructors. Okay, let's continue. This is a bit complicated, but if we understand this, we understand the framework. Now, they have the same superclass, but there is this examination called can update. Now we have this new widget, but this is the old widget. We compare the old widget and the new widget, meaning that the widget from the previous frame and the current frame. So what is happening in this can update? The framework compares the runtime time of the old widget and the new widget, and then the keys of the old and new widgets. If they are the same, then we can reuse this element, and we just need to update it with the new configuration, with the new widget, but the render object is reused and element is reused. Okay, until now we are good. Let's continue. In the case 4, we check that it cannot update because either the key is different, or the runtime tab, we have a different widget in the next frame. Then what we are doing is similar to case 1. We are deactivating the child and then inflate the new widget, which creates a new element, which is this new child. And then if the child is not null, meaning that there wasn't an element in the previous frame, then we need to add a new child, new element for that location, which is going to be our new element, and it is going to call inflate widget. This new widget will be inflated and it will return the new element. Okay, this is a bit complicated, but we will come back to this in the next slides. As I said, if you want to understand how the build system works, if you want to optimize, we really need to understand how this can update method, this update child method is used and utilized. Okay, I need to take a break. Let me check if there are any questions in the comment sites. Okay, no, there is no question, but feel free to send questions. Let's now talk about the stateful widgets. Why I wanted to talk about stateful widget here, because we can call these build methods inside the state object of the stateful widget, and when you have this extra build called, then all the subtree of the stateful widget will be called. So if you want to optimize, we want to minimize this number of calls, and we need to understand how the stateful widget works. So Flutter has stateless widgets and stateful widgets. The difference is that in the stateful widget, we track data associated with a widget. For example, in this case, we have this stateful widget on page, and then when it is inflated, it created an element as a stateful element, which extends the component element. See that when the element is constructed after the widget inflation, the state object is created. So element has an associated, the stateful element has an associated state object. And the lifetime of the state object is really same with the stateful element. So element is mounted in its state, and did change dependencies methods are called. And this is one-time call, and this is where we, for example, initialize our data. And then after the initialization, because this will be called only once when wanted, but after the initialization, we can call this build method by calling set state method inside the state object of the stateful widget. For example, here there is this button, and when a button is pressed, we call set state, which will make this widget dirty, meaning that it will need a build in the next frame. And we can do this during the lifetime of this stateful widget. But there is also one more important method here, did update widget, which can be very useful, and it is actually useful in our scrollable bottom sheet page. For example, we have a stateful widget like a page, and then when the page index changes, the configuration changes, because like the index number is the configuration, is a property of the widget. When it changes, it will call this did update widget. And then here, I can actually trigger the animations that during the pagination. So did update widget is useful when there is this here, just a second. Here in this case 3, there is this can update method. So when the widget is the same, has the same runtime type, and the key is the same, and in the next frame, it will update the widget. In this case, it will call did update widget here. And then after that, the build method will be called. So no need to call build set state again here to trigger a build, because it's guaranteed that there will be a build call after this did update widget called. Okay, let's continue with this dispose. There are more methods, but I just wanted to show the most important one. Dispose also very important, because this stateful widgets, actually it's tracking data, right? We said it's useful when we track data, and it means that we have resources there. And when the element is unmounted, the state is also unmounted, and this is where we dispose and get clear our resources. For example, if we have animation controller in this stateful widget, we should dispose the animation controller in this method. Okay, let's continue. We have any questions? I'm checking. No, let's continue. Next. Part 2. This was the first part where we talked about this element and render object concept and optimization. Now we will talk about why Flutter. We say Flutter is fast. It supports 60 frames per second, uses device GPU. Why is fast? The answer is simple is fast. Flutter has a simple rendering pipeline. This is one of the things. Another thing is that Flutter simplifies how the graphic library, how it accesses the Flutter graphics library. We will come to that in the next slide, but before that, I want to again promote one more talk from Adam Barth. There is this Flutter's rendering pipeline talk from 2006, very early days of Flutter, but it really explains well how this rendering pipeline works and how the system is really good with this Flutter, which makes it fast. Okay, now we will talk about this React Native, Flutter, and native development. This is the exciting part. When we are developing native applications, we use Android. For Android, we use Java or Kotlin, right? For iOS, we use Swift, Objective-C. What we are doing is that we are using Android's, for example, material library, or Android's their own View, for example, the system library, native SDK, when we are developing native development. What is happening is that native library is actually a high-level library that communicates with the underlying graphics library, which is let me check what was the name. For iOS, it was Metal, and for Android, what was it? Yes, it is nowadays. I think it's Skia, but Skia is also, just a second. I will double. Yes, library OpenGL. Yes, OpenGL. Okay, so when we are developing with native, when we are developing for native applications, we use the native SDKs, and native UI libraries communicate with the underlying graphic rendering API, which communicates with this, GPUs. For iOS, it's Metal. For Android, we have OpenGL, but as far as I remember, Android is also using Skia. Somebody can correct me on the channel. I will double check this. Anyway, what is happening with other traditional cross platforms? Remember that we were here, for example, platform 1, Android. The UI library is Android's native SDK, and then it communicates with this underlying graphic rendering API. For iOS, we have Swift and its own library, Swift UI library. And then it communicates with Metal, iOS Metal. And then there is another platform. It communicates with its own the graphic library coming with the operating system, the platform. Anyway, okay, what is traditional cross-platform code base do? What do they do? For example, React Native. In React Native still shows the native components on the screen. So when you see a button on the screen, it's actually Android button or iOS button. Why? What does it do? React Native has its own JavaScript UI thread, and then there is this bridge system that translates it to system UI library. And then it is still doing the same thing that the native applications, natively built applications do. So from performance point, not performance, sorry, but from user experience point, it's the same usage. You can differentiate if you are using a native library or React Native. But what Flutter does is a bit different, because Flutter does not use the system libraries. Instead of accessing these platform rendering APIs, it uses its own rendering library, which is called Skia. Here, in traditional cross-platform development, we have one-to-many relations. So we have JavaScript. It is translated to Kotlin, and then translated to native SDK, and then translated to the rendering API in the device. For Swift, it is the same. There is translation process in here. But what happens is that Flutter, when we have a Flutter application, it comes with a package so that it has the virtual machine, Dart virtual machine, Dart VM, and also a rendering API inside. So it doesn't need to translate. So it encapsulates this translation process. So in the engine layer, it is communicating with the Skia, which supports Vulkan, Metal, OpenGL, this kind of graphic rendering API. Skia supports these graphic rendering APIs. What else? Let me check. Yes, so Flutter is performant because it is directly accessing this device's GPU with its own rendering library, and it is capable of providing 60, 120 frames per second. And what else I can say here? One more thing. Yes, you might notice that when you have an APK or this IPA, the output, application output that you push the App Store or Google Play, its size is a bit more than natively built apps, because Flutter also includes this rendering API library and also virtual machine in this package. Okay, now let's talk a bit more about this. I shared this on Twitter, I think a couple days ago. It had really good attention in the community because it is really true. People keep saying that everything is widget, and it is actually not true, but I don't see that it's a problem saying this, because Flutter wants us to stay in the widgets layer as much as possible. So I mentioned about these render objects, but instead of building things in the rendering library with render objects, we should still use the widgets as much as possible. Why? Because widgets layer is simple. It's abstraction, and not abstraction, of course, but it's just like it helps to write code easy and fast. Because in rendering layer, I mentioned about those like updating and then all this complex logic to make Flutter fast, right? If you are in this, then you are actually intercepting this. You are in the process of making it optimum. But Flutter framework already does it for you. And when you are in there, you are trying to do something to achieve something special, then you might actually end up some optimization or performance issues, because it's a bit more complex than the widgets layer. Not a bit more, it's actually very complex than widgets layer. With widgets, we just provide the configuration, there is build, and then element is updated, render object is updated. So what I want to say in the end is that we say everything is widget because we want to work in here. Under the hood, Flutter takes care of this performance, and it just draws the pixels on screen. You just tell with a widget tree what you want to see on the screen, and then Flutter does it for you. Draws the pixels, does the layout, painting, compositing bits, and then showing the pixels, communicating with GPU for you. Here, I mentioned that in the previous case, React Native and traditional cross-platform libraries, they use these platforms libraries, right? With, for example, written with Swift or Kotlin using a bridge. But Flutter, actually, what it does, it uses its own widgets library set, meaning that it's not going to use the libraries coming from the system, but the framework itself, libraries, its own library, its own widgets. So Flutter knows that what a material button looks like. It doesn't need to communicate with the native SDK to draw a material button because it already knows it. Here, thanks to this framework, it comes up with comprehensive set of widgets. It has material widgets from material design and from Apple, what was it called? Let me check. It's in my notes. Yes, human interface guidelines. It's actually called Cupertino library, but Cupertino is not the official name. It's just, I think, a name to represent Apple's component. But anyway, in many cases, like 99% cases, it's enough to work in this widgets library, in this widgets layer, work with widgets library, and then get what you want, what designers tell you to do. But some designers can go crazy and want you to do really like artistic, super crazy stuff that is not easy to achieve using the API in the widgets library. In this case, you may want to go to rendering layer, and then, for example, you may want to work in different layouts. You may want to perform the layout by yourself in a different way, and then you may want to intercept the paint phase. So you can do this, but don't do it. It's complicated. Still, try to stay in the widgets layer as much as possible, because Flutter still has some widgets that can help you to be in here in this rendering phase, because there is this flow widget, for example. With its delegate, you can work after the layout phase, just before the paint phase. And then, for example, there is this custom single child layout, custom multi-child layout, where you can actually perform in the performing layout phase. Yes, we will come to that, but not in this one, because it is a really big topic. In Flutter Wiki conference, we will talk about the flow widget, and at the end of this talk, we will talk about this custom multi-chart layout. Let's continue. Rendering pipeline. Simple is fast. This is the motto. And what makes Flutter fast is this simple rendering pipeline. One layout per frame. Flutter performs one layout per frame. So this is how a frame is rendered, actually. We will talk about this. But before that, I added here this blog post from Alibaba Clouder. If you have a chance, please read it. It's really comprehensive how this rendering pipeline works. And I got this screenshot from this blog post. So what happens when we are drawing a frame? For example, when there is an animation tick, and then a new frame will be drawn. Or there is a user gesture, and then there is a, based on that, we need to change the appearance of the UI. So we have a different widget set. We need a build. So anyway, we have this tick or a new build a new frame starts. First, we will start with the build phase. We will provide the framework a widget tree, and then the widgets will have corresponding render objects, and then these render objects will be laid out. The bits will be composited, it will be painted, and then it will be sent to the frame here. There will be composition and rastering, and there is also this semantics for accessibility. And then GPU renders it, and then what you see in the end is the pixels. You see final thing. But as I said here, we have widget tree, then element tree is created, render objects is created. After this paint phase, we have a layer tree. And then this layer tree is rastered and composited so that pixels are shown. What I want to say in the end is that it's not only the 3 trees of Flutter. Flutter has more trees, but these are the things that we really need to understand how it works. We don't need to go deep down than this layer tree. I would say that it is good enough to understand the layout phase and the paint phase and the build phase. These 2, 3, 4 here to be able to do good things with Flutter, to understand the framework. Yes, we see here the build owner and then pipeline owner. We will come to that in the next frame. But just want to summarize. When a frame is drawn, build phase starts, and then layout phase starts, compositing bits, painting, and then in the engine layer, there is this compositing. Finally, the frame is drawn and build owner finalizes the tree. Okay, I will take another break here. What is the time? Good, I'm almost ending. Let's now start writing our app. We have this run app, right, in our apps. So actually, what we are doing in this rendering pipeline, we are providing a widget tree to the framework. At the same time, we are marking the widgets like this needs builds, this needs builds. But before that, everything starts with this run app. What is run app? Run app actually does two things. One is attaching to the root widget, attaching to the widget tree, and then it does the first build. So in the first build, there is no element, right? We only have the widget tree. It will be only one of these cases that we create elements, we inflate the widgets. And then this is done in run app, inside run app, attaching the root widget. And then the second thing it does is that scheduling warm-up frame, but it's in this widgets Flutter binding. This widgets Flutter binding is really important class. It extends many of these bindings, which all has different responsibilities, but it is actually the glue between the framework layer and the engine layer here. There is in this layer, in between two layers, there is this widgets Flutter binding. It's really important, and it's a singleton. If it is already instantiated, we don't need to, the framework doesn't instantiate it. This widgets Flutter binding has two things. One is this build owner, which is responsible of build phase. And then there is pipeline owner, which is responsible of layout phase, paint phase, and compositing, the rest of the rendering pipeline. Okay, now let's see the big picture. Until now we had this background information, but let's see. We have this widget tree, okay? And then we have stateful widget here. It has its own child. Let's say that in this stateful widget, in the build method, we provide this subtree, and inside this subtree there is this widget L. When we are pressing it, we call the set state method for this state object of this stateful widget. Now let's see what's gonna happen. First, we pressed on pressed, we call this method, and then in this method we call set state. What does set state do? Set state calls mark needs build of this element in this stateful widget C. So element C, mark needs build. What does this mean? Build owner will schedule build for this element C because it is dirty. And I mean, after this mark needs, inside this mark needs build method, there is this build owner which schedules the build for this element. And then inside the build owner, inside this method, this element, stateful widget C, the element of this widget, is marked as dirty. What does this mean? When there is a new frame, so you press this, the build doesn't happen in the same frame of this, because in every frame, we perform one build, one layout, one paint, one rendering pipeline. We don't do things twice. So when you press this, in the next frame, what is happening? The draw frame method in the widgets binding, which is, I mentioned here, this class, which is the glue between the framework and the engine layer, what it does? It calls the draw frame, and then build phase starts this build with the build scope, and then this element A, because it will start the build from the root widget. So in the new frame, we start the build phase from here, and then we will check all the dirty elements. what dirty element we have here? This is the dirty element of this widget. What is going to happen? It will check update child of its widgets elements. Sorry, the element has these two child elements, and this element examines if they can be reused, because we want to optimize, right? So this f is a const widget, so it is here again. This case, which is the optimum case. We don't call even this update method, meaning that there won't be any other build here, because the framework knows that everything is same in here. But here, this is not a const widget, and then it will check if it can update. If it can update, then it will call the build method. So what's going to happen is that it will call the rebuild of this method element, and then the child, for example, if it can update, it will update the render object of this. And then here, for example, and then it will go down here, because as I said, build phase happens from top to down. From here, we went here, and now we are here. Here, it will check its own children. This is a const widget, so we don't need to perform build here, because it's a const. We know framework knows it's exactly the same widget. But here, it can update. It's a different widget. Let's say that there is an update here, and then it's the same for these two here. They need to be updated. So there is this going down, and this is called build phase. What happened again? Pressed here, made this element dirty. We marked as dirty, and then in the next frame, this update child method is called from top to down. The parents call update child method of its children. Let's continue. I mentioned that marking as need build, right? In what cases we have this? One case I just mentioned, that set state. With gesture events, usually we call set state with stateful widget. Another thing is this with these inherited widgets. Inherited widgets. So it's not really something that we use all the time, but we, of course, indirectly use with state management. But what happens is that the child depends on a parent inherited widget. So whenever that changes, the child also changes. It's another way of calling it. For example, when the element is activated in the widget tree, also reassemble. This is really interesting, because when you press hot reload in Android Studio, this reassemble calls, and it also starts a new build process. Yeah, so these are the methods that, and also the first one, of course, when we are attaching the render tree, the root widget, of course, it does the first build. Okay, last slide, I hope. Now we talked about, in the previous slide, we talked about the build phase. Build phase. Now let's talk about the rest of the rendering pipeline. Here, we talked about build owner, takes care of list of dirty elements that needs build, the elements that needs build. And then when we are building, we check update child method, right? If this update child method, if it requires update, what we do, we also update the render object. For example, you have a different widget configuration, but it's the same runtime type, same key. What we do then is updating the element, which updates the render widget. If it updates, for example, width and other like some layout related things, then it needs a layout, right? Then we mark it as needs layout. If it's, for example, if its opacity changes, then we mark it as needs paint. If it is visibility change, it's needed for accessibility reasons, then semantic updates is needed. But during this update child method, we actually mark which phases are needed in the next one. So not in the next one, which phases are needed during the build phase. And then build phase finished, it ended. Now we continue with layout phase, compositing bit phase, paint phase. During these steps, it's happened one by one. During these phases, we all perform layout only on the dirty layouts. We perform paint only on the dirty render objects. So this is also another optimization. And then after all these sent to GPU, render object sends bits to GPU, pixels are drawn, semantics sent to OS, and then it's completed. The frame is drawn, and then it goes to the another frame. It does again check of dirty lists to be built, dirty layouts. It's every frame we have this. This is simple and fast. This is why we love Flutter. Final thing. I know I took a bit long time, but we are getting there. Yes, why we want to learn about this rendering pipeline, why we want to understand this Mark Nix layout, why we need to know this. Because we need to understand how this system works. I mentioned that layout build, it goes from elements from top to down. So what happens is that in the layout phase, the widget passes down constraints to its children. Okay, these are your constraints. You can size yourself within these constraints. And then the child returns its size back to the parent, and then parent decides how to lay out. It performs the layout. So for example, there are different kinds of layout. For example, think about flex layout, right? In flex, we have inflexible widgets, list of inflexible children and flex children. So how does it happen, the layout? First, this parent lays out the inflexible children, has this fixed size. It cannot go more than its entering size. It's like forced size. And then after that, this parent knows the remaining space, and then it gives the remaining space to this flex, because this widget says, I'm flexible, I can take this space. So here, what I want to say is that parents give the constraints, and then child tells its size, and there is this logic, perform layout logic in the render layout. For each logic, for example, it can be flex layout, some other layout type, there is different logic. But let's say that we want to perform something customized, something special. I just want to give this example in our bottom sheet. For example, we have this, when we call show bottom sheet, it pushes up the bottom sheet in a root, right? This is a model root, and it's actually full screen. But what we want to do is that we want to have the page content here, and then this barrier, this empty space, so that when this empty space is clicked, we want to pop the root, and yeah, this means the bottom sheet. So what we want to do is that this bottom sheet page, it doesn't have a fixed size. Its size depends on its children. So what we do here is that using this custom multi-child layout, we are actually, this is a widget. We have this scaffold. We give this custom child layout, and then we will give 2 children to this custom child layout. We will perform a customized layout, but we can't perform layout, right? Because we are only working in the build phase with widgets. And then framework takes care of perform layout. But there is this widget in the widgets library that helps us to work in the perform layout. To do this, we just use a delegate of this widget. We will extend this delegate, and then we will provide the children, for example, this gesture detector to detect the tabs, to pop the root, and then this scrollable button sheet container. Let's continue. So my last slides, I'm sorry it took a little bit more, but let's see how we customize this scrollable button sheet delegate. We provide it to this widget custom chart layout. This is not a widget, this is just a delegate, and we write the custom performing layout logic in this delegate. So what do? We get this because the layout is performed here from top to down, right? When I'm performing the layout of these two, the layout is already performed in the parent because it goes from top to down. So this is laid out, and we already know the size of this one. So when we are laying out the children, now we know the size of the parent. So we need to use this size. How? First, let's lay out the bottom sheet. Parents, with what we said is that parents should provide a constraint. So here, constraints go down, sizes go up. Here, parent should provide a constraint, which we are here now customizing. We are giving our own constraint to the child, which is maximum 90% of height of the screen, 40% height of the screen, and then we get the size of the bottom sheet. And then we are laying out the gesture detector here. What we are trying to do is that we have the height. The height is because we already performed layout here, so we know the size. And then the remaining size will be the size of the this container. So we again give the constraint, and then we will get the size. So now we laid out two of these. After laying out, there's this positioning, which is usually happening in the after laying out everything. For example, here we are positioning the layout to 0, which is here, and then the height of the gesture height, and then we will, meaning that we will go until down. I mean, the coordinate will be here 0 and the height of this, and then this will be placed here. The offset is, sorry, I was wrong. Yeah, I will say again. This empty container here, this gesture detector, should be positioned at 0, 0 here on top. And then this bottom sheet component should be positioned here, which is 0 and the height of this. There is this should layout, but I'm not going to talk about this. Okay, this was it. Vince, thank you for waiting. It took 1 hour. I talked a lot. I hope it was useful.
Could you hear me?
Yes.
So thank you, Cagatay. It was a great talk. So it's deep for Flutter to understand how it works. And I want to say that's why using constant and final is a good practice for Flutter to build your widgets. So, and that's why state management is so important. So rebuilding only the widgets that should be updated will decrease the amount of work done by the framework for each widget. And that's it.
But I just want to say that this is really too much information to digest. That's why this video is recorded, and that's why I'm working on this Medium post series. Actually, I want to do something here. It's not the final, but I'm going to share the draft version of this story, of this post, in the link in the chat comments. So if what I told you was confusing for you, please read my blog post that I'm going to share in the comments. So digest this talk, and then really you will understand how to have a performant app.
So yes, you can share it in the comments in the right sidebar. There is
but I think I cannot write in the comments, but I will try to do it. I wrote in the private chat in the backstage. If someone can post it in the comments, that would be okay. Already posted. Yes, so this is the draft version. It's not finalized, but you can read this one. And then I think in the first week of February, I will be sharing the full series of articles, which will have around 6 and 7 articles. And also follow-up talk is after this one in Flutter Vikings, 3rd of February. I will be there.
Flutter Vikings.
Yes.
So yes, we learned a lot from your talk, and looking forward to see you completing it in the upcoming Flutter Viking conference. It's the big Flutter conference in Scandinavia, right?
I think it's the biggest in Europe and one of the biggest in the world, I think. Yeah, like the speaker list is really really good. Really, I'm looking forward to it. Not for my talk, but really all the interesting talks. There will be Tim Smith will be there, and there will be Felix, Remy, very famous people from the community.
Yes, also there is there is many speakers. Alwa Daniel, there is Felix, and many more. many more speakers.
And I will be. I just mentioned the this performing layout, customizing it in my talk. There, I will mention intercepting in the paint phase, and then doing this, implementing this motion when switching between the pages during the navigation. That's it.
Okay. So, as I said, thank you, Chata. It was a great talk, and thank you for accepting my invitation to be in Flutter
I'm really
Tunisia.
grateful. This is really important for my series. This was the second step, so thank you very much.
You are welcome. This session would be recorded, and you can share it with anyone on YouTube. So thank you very much, and looking forward to see you in Flutter Vikings.
See you. Bye bye.
Bye bye.
Bye bye.
Bye, Swins.
Hello, Vince.
Hey.
Hello. I'm happy to see you here with us. So I'm sharing your podcast link in the screen.
Thank you.
It's flatten101.dev. You are making this podcast with the famous Flutter developers and the Flutter engineers from Google, from Very Good Ventures, and from every place in the world. So we will continue with you. You will talk about Dart Null-Safety, why we have to use it, and gives us a type of tips that makes the migration easier than ever.
Yeah, awesome.
Okay, so you can.
I'm already sharing my screen. I think you might need to select it for putting it on stage, right? Perfect. Yeah, thank you.
So you can start.
Okay, awesome. Okay, so as mentioned, my name is Vince, and today I'm going to talk about Null-Safety migration. Whoops, sorry. All right. And before I get started, I just wanted to thank you all for attending this event. I'm really glad that you joined the event, and also special thanks for people organizing the event. And I'm just really glad that we could have this event. Here's a short outline of my talk. First, I would like to share a bit of a context of our Flutter usage and migration, and then a very short Null-Safety introduction. It's not the latest feature of Dart and Flutter, so I will not go into details. Just to give a quick idea, maybe if you don't have that much Dart experience, I think this short introduction will be helpful. Then I will talk about the Null-Safety principles and a couple of migration tools, or the migration tools that are available for you, and then just go through the unsound Null-Safety, why that's important, especially if you are working on a bigger project and you need to migrate a legacy project. And then I will talk about what we learned, what we didn't really discover before, so what we couldn't learn from articles or YouTube videos. So I'm working at a company that is called MediaMarkt. It's a German consumer electronics retail company, but they are present in many countries. So they are present in Turkey, Germany, Spain, Austria, Hungary as well, Sweden, and a couple of other countries that I'm sure I'm forgetting. And it's not like it was founded in 1978, so it's been here for a while. And at one point, so they started with these traditional stores that you can see on the picture, and then they slowly switched to web, of course, and they also had a mobile app. Originally, we had an Android and iOS mobile apps, but of course, it was before the time I joined the company, but we had issues with Android and iOS. Of course, the things that always happen with two different native applications. For example, one of the things maybe you cannot hire for the two teams at the same rate, so you cannot have feature parity. So maybe on the iOS teams, you have twice as many developers as on the Android team, and then you cannot release the features anymore at the same time. So also hiring is more difficult because you really need to hire people who specialize in Android and iOS. And for this reason, the company have taken a look at Flutter, and we decided to use it. And we are using it now for Android and iOS mobile applications. Currently, we use it in 4 sales lines, so in Germany, Austria, and Spain. And the company also has a second brand in Germany that is called Saturn. And we also plan to release it to more countries. As I mentioned, the company is present in many countries, but we want to, so some countries still have the legacy applications that are native iOS and native Android. And yeah, we have around 250,000 daily active users. This is also changing based on basically the time of the year. So for Black Friday, we had 2-3 times that. Currently, maybe we have a bit less. So it's fluctuating all the time. And we have around 15 developers and like a considerable legacy, so not like a considerable code base that we, of course, we need to maintain. So this is the context, and now I would like to talk about the null-safety principles. So in Dart, the first null-safety principle is that in Dart, types, if you have null-safety, types are non-nullable by default. So this means that if a variable can contain null, then you need to explicitly say that it can contain null. I will give a very short introduction to null-safety. It's based on, inspired by the null-safety code lab. I will not go through all the examples that the null-safety code lab has because I don't want to just read the documentation. It would be very boring. But it's a short, tutorial. You can finish it in 15 minutes. And if you are not experienced with null-safety in Dart, I really recommend you check it out. They go into details that I just can't do right now. So this is probably, you can all understand this code, and in Dart without null-safety, this code would have run. But with null-safety, this will complain because, as I mentioned, if a variable can contain null, you need to explicitly say that it can contain null. And in this example, on line 2, we have an integer. We declare the a integer, and we say that it can be an integer, but we try to assign the null value to it on line 3, and this will now give an error. Then, as I mentioned, that we need to explicitly say that a value can be null. Then this is what I meant, that we need to add the question mark after the type. So on line 2, we write int question mark, and then Dart will allow that we assign a null value to a. There will be no warnings, nothing. Everything will run as expected. There are 2 things that I wanted to highlight. One is the null assertion operator, which is this bang sign, the exclamation mark. And I will explain why and how and when you need it. So let's take a look at this example quickly. So we have a list that could hold nulls, and you know that it can hold nulls because here we have the question mark. So it can hold integers and also null values. And you can see that, okay, there is the 2, there's the null, and there's the 4 in it. So this is a list that can hold null values. And then on line 4, we try to access the first element, and we try to assign it to an integer type. So there is no question mark here, it's not nullable. And Dart is very pessimistic, and it will say that, okay, I don't know about that. we have a list that could hold null values. And in that case, the first element could also be potentially null. So even if you know that the first element is not null, Dart cannot be sure. So Dart will not allow this to compile. It will complain that we need to change something in your code. What you can do with the null assertion operator is, with the null assertion operator, you are basically saying Dart to get out of the way and just trust you that, okay, you are basically promising Dart that this will not be null. Of course, if you lie to Dart, so to say, then of course this makes runtime errors possible again. So use it with caution. And one more comment that I wanted to say, that this is probably a terrible code. So this is probably like a code smile. If you need to do, I mean, of course, occasional null assertion operators might be convenient and you might need it. But like, you should not create this kind of list. It's just, it's probably a code smile that you should take it's a sign that you should take a better look at your design. The next thing that I wanted to mention is the type promotion. So we have a function, getLength, that can take a nullable string. So it can be either a string or null. And then Dart, so we try to return a length of this string, but Dart will not allow this. This will not run. This will not compile because the str can be null. And if it's null, then getting the length of null doesn't make, so null doesn't have a length. And you cannot just, and that's why you cannot unconditionally access this length. There are many ways to fix this, and this is just an example to demonstrate type promotion. But one way, just to demonstrate type promotion, you can add a null check. So you check if the string is null, then let's say if it's null, then the length, we define it as 0. And if it's a string, then we just get the length of the string and we return that from this function. And now this will run because Dart is able to analyze this and figure out that, okay, let's say if on line 1 we receive a null value, then on line 2 this conditional will be true, and then we return. So this means that on line 4 there is no way that str can be null. So this is Dart's control flow analysis can figure it out and basically make it nicer to use null safety and null safety features with Dart. So that was the code example that I wanted to share because I will be referencing this later. So types are non-nullable by default. If a variable can contain null, then you need to explicitly say that it can contain null. And the reason why it's very good, that it turns runtime errors into analysis errors. And the reason why that is very important is because let's just think about what happens if you introduce a runtime error to your application. So you are coding, you make a mistake, you introduce a bug, you don't notice the mistake, no one in the code review notices the mistake, and you release the app in the app stores, maybe at the end of the sprint or at the end of the week or whenever. But basically what I'm trying to say is that there is also time there. And then you notice that something went wrong in your crash reporting tool, for example, like Sentry, Crashlytics. There are a couple of tools where you can analyze your crashes, and then you hopefully check these crash reporting tools often. Then you notice something went wrong. You need to find someone who fixes this bug, because maybe it can be that, okay, days or maybe like 1.5 weeks have passed. And then maybe the original person who introduced the bug is working on something more important, went on holidays, whatever. Or maybe you can even get the same person to fix the bug, but then you need to fix the bug. Then that's again annoying, because again you need to understand the context, how it happened, why didn't you take care of null? So again, this is very bad, because so a lot of time passes between when you introduce the bug and between the time you fix the bug. And again, you still need to release the app again. So a fix, so between the time you introduce a bug and the fix, it can really it can take days or weeks to fix that bug, depending on your processes and priorities. So of course, if the whole app crashes, then you will probably make it a very important thing to fix. But if there is some small, not frequently visited part of the application, then maybe it will not be that important. And yeah, but let's compare that with the analysis error. So you are again you're creating a function or whatever, you're writing your code, you make a mistake, you forget about null-safety, and then immediately within sub-seconds, you notice in your IDE that you have this red squiggly line, and okay, whoops, I forgot about null, and it's time to fix it. And so it's a very strong contrast between fixing something in weeks versus seconds. So that's why it's I think it's a very, very important thing. Now that I talked that wow, null is bad, no, it's not what I want to say. You don't need to be afraid of null. Null is not bad. Not knowing that something can be null is bad. So if you don't handle the null case, that is bad. But of course, you can still use null values. So it's a very good way to represent that some information is missing. So maybe not everyone has a middle name. So the null is still valuable. It's still useful. But of course, making sure that a code handles null correctly is very hard to do manually, and there's no amount of code reviews that can help with that. So I know you pay attention when you code. There are in teams usually code reviews, but still mistakes can happen, and this is something that is very hard to verify manually. And one thing that I wanted to mention is that I think in most codes, when you think about most functions or classes that you, so Dart has taken the decision to make the variables non-nullable by default, which is very common when you are writing code. And I think this is a very important detail, that instead of making values by default nullable, we make them non-nullable because it's much more common that you use it that way. Only that in languages that don't support null-safety or don't support these null checks, it's very easy to miss. But anyway, back to the null-safety principles. The second null-safety principle is that Dart's null-safety is fully sound. So when the type system determines that something cannot be null, then that thing can never be null. So runtime checking is no longer necessary. More of the heavy lifting happens at compile time. This also means that the compiler can get rid of unnecessary checks. This results in fewer instructions. The short version of this is that you will have smaller binaries, your apps will run faster, and also you will have fewer bugs because the type system can help you prevent these bugs. If you want to know more about the performance results or consequences of null-safety, I really recommend you check out this short article on Medium on the official Medium page of the Dart language by Vijay Menon. They go into how Dart over the version changes can get rid of more and more instructions, and this results in basically also smaller binaries and faster code because null checks are no longer necessary. Then another very important thing is that Dart's null-safety is incrementally adaptable. So this means that you can run non-null-safe code alongside with null-safe code, which is very important for projects that existed before null-safety was introduced. Of course, I think I already mentioned, but null-safety is now the default, and it's been the default, I think, since last March. So if you start a new project, you don't need to worry about any of this because you are running in null-safety. The increment incrementally adaptable nature of Dart is important for projects that have been around for maybe a year or two. Oops, I need a... So it's very okay. The fact that you can incrementally adapt Null-Safety in your application is very important, because you can work on the Null-Safety migration, and you can release new features and bug fixes at the same time. So maybe you have, let's say, 10 people on your team. Maybe you dedicate 1 person or 2 people for null migration, and the rest of the team can work as usual on new features and bug fixes. Any urgent release that you need, this is still possible. You don't need a code freeze. So the code freeze is when you say your team that, okay, now, so you work on, you work on a feature or you work on a big release, and then in the last 2 weeks, you have a code freeze and you are just testing or fixing bugs. And that is not necessary because Dart is incrementally adaptable. You can release continuously. You can also pause the migration. Let's say there's a big release, you need to release a bunch of features, then you can pause the migration and come back to it later when you have time. You can also mix new, like no-safe code and non-no-safe code. So you can, for example, decide that new code will be already written in Null-Safety, so that we don't introduce new code that will have to be migrated later. But for example, for old code, maybe you give the freedom of choice for your developers to decide, okay, is it like a tiny mistake, a tiny change to this old file? And would it be hard to migrate? And you let the team decide this. And if, for example, a fix is very trivial and easy, then you migrate that file. But if you have a very urgent fix and that you want to release and you don't have time to properly test the changes to that file, maybe you just don't migrate it in the beginning, or you don't migrate it immediately. So it's very convenient. So we decided to migrate because that way we need to write less code. The code is much clearer, and we basically let Dart's type system validate what it can. So we do not leave this up to humans, because it is very error prone. It's very hard to keep in mind the whole application, what can be null, what can be not, what cannot be null. So we basically let the type system do its job. It can do everything in like seconds or probably sub-seconds, and what it can do it correctly, and humans could not do it, no matter how much time would you give them. The applications will be also smaller and faster, and we wanted to keep up with the ecosystem and the community. So we want to take advantage of new packages that are usually faster than, so like the dependencies usually improve over time, and we don't want to be stuck with old versions. Another often overlooked, I think, good quality of Null-Safety is that the PR reviews are easier, because you don't need to like nitpick that, okay, if you used Dart before, it was very common that you added the add required annotation or decorator, and then you had to add like also the assert null checks, and it was so it's just so easy to add one and not the other. Maybe I added the assert that it's not null, but I didn't make it required, and that was very annoying. That a lot of people, like, of course, like everyone on the team, have forgotten a couple of times. And that way, with Null-Safety, we just don't have this discussion at all. We just know, okay, is it nullable or not? And Dart verifies everything for us. Right, so we decided that we wanted to migrate. We have taken a look at the migration tools. The first important command shows your dependencies with and without Null-Safety. So it helps you know like how difficult it will be to update your dependencies. Then there's this tool that automatically upgrades to the latest versions supporting null-safety for you, and it updates the pubspec YAML files automatically. Initially, what we thought, so we had this idea that we should migrate in as small steps as possible. So we initially just try to update the dependencies manually, just fix the things that we need to. But there were so many interdependencies between the packages that we just decided to, like after a couple of updates, manual updates, we realized that, okay, it's not going to work. We need to use this tool. And it was really just 2 seconds to update everything correctly, at least from the pubspec file. Of course, the dependencies could introduce breaking changes, in which case you need to investigate that and make sure that everything works still correctly. There is this very neat little tool, the Dart migrate tool. This is basically, it helps, so it opens an interactive web page, basically, on your computer, and then it gives you hints and recommendations of how it would migrate things for you. Most of the time it works very well, and if it doesn't work very well, then you can still use the, it's called hints. So you can basically tell the Dart migration tool that, okay, Dart migration tool, you decided that wrong. This is not nullable. I know it's not nullable. Please make sure that this will not be nullable when the migration is applied, and rerun the analysis for me. And one more thing that I wanted to highlight here is that you can see a list of files, and you can, as I mentioned, adopt null-safety incrementally. So you could just select and deselect files, and those files would not be migrated, which is also very helpful. You can, of course, also migrate by hand. This is I would only recommend it if you have gone through the migration process a couple of times with the migration tool. But if you want to do it for smaller projects, what you need to do is basically you just update the SDK constraints in your pubspec YAML file. You fix the errors, run the tests, and if everything is fine, then you can just ship your application or publish your package. This is really only for small projects, but it's if you are experienced with migration, it's a very simple and fast way to migrate. I did this migration by hand. For example, this small package, it's a plugin for iOS and Android, but for example, the Dart code is just a couple of maybe hundreds of lines of code, and then I just didn't want to open the migration tool. It was much easier to just edit the SDK constraints and just fix whichever, like I had a couple of errors and it was very easy to fix those. So we did a bit of research, and then we were very optimistic about the migration because there are all these amazing tools which are really good. And we thought that, okay, we run these tools, then we run the static analyzer, we run our tests, and voila, our application is migrated. Everything is good. But unfortunately, it didn't really turn out that way. We also had a couple of requirements and, let's say, constraints for our null-safety migration. We have the rule that we want a code to be reviewed before we ship it. So we had to have code reviews. We couldn't allow code freeze because we always have important features that need to be released soon. Then, so we cannot afford a code freeze for weeks or months because we want to ship features, and that's very important for us. We also could not dedicate too much effort to this. So in the beginning, we started with 2-3 developers working on the null-safety migration in the earlier phases. But then we had maybe one developer working on things, and also sometimes we didn't have anyone because we had, for example, Black Friday. For the Black Friday releases in consumer electronics, it's a very important part of the year. So we had to release a lot of features, and we couldn't spend time on no-safety migration. Of course, we wanted to integrate with the main branch very often to have this kind of continuous integration, continuous delivery, have it possible. And yeah, as mentioned, we decided to write new code in no-safe mode, but for the old code, we allowed basically people to make a judgment call and decide if they migrate immediately or not. So updating the dependencies was a bit of a pain, because now when you update your dependencies, the package maintainers can also introduce breaking changes that you need to fix first. You need to understand that, is it a breaking change? Is it going to introduce some nasty bug in your application? So that was a bit of inconvenient. So most packages or most dependencies that we have that relied on build runner and generated files had to be updated all at once, because otherwise the build runner didn't run. Like you need to think of JSON serializable, freezed, different routing packages, and assets generation and things like that. So for that, we used, so we had to basically fix all of them at once, because otherwise the build runner would just not run, and then you cannot run the application as well. So also migrating in one gigantic pull request is not really manageable if you want to have code reviews. And yeah, what I wanted to mention is that the tools did help. So we could not have, so here what I wanted to say is that we could not have migrated the entire code base in one single PR, because it would be very difficult to basically just understand what's going on. And what you would basically need to do is just close your eyes and click on accept and merge button. And that is, of course, a bit risky. But the tools did help a lot. So of course, you should start with the tools. And if they help you, and if they get you all the way to no safety, you should definitely start with the tools. But if it doesn't work out for you, if you cannot migrate in one step, then there is the unsound no safety, which means that some dependencies are no safe and some aren't. Some files are no safe and some aren't, and this enables incremental migration. And this way, you can keep your pull request small, and that makes it very easy to review. But of course, what you need to understand is it also comes with downsides and disadvantages. So the disadvantage for us, the most important disadvantage, was that the nulls can sneak into your null-safe code from non-null-safe code. So what I mean by this is when you have non-migrated files, Dart cannot know that, okay, this value is a nullable int or a regular non-nullable int, because in the old versions of Dart, you didn't need to declare that. And when you pass that value into an already migrated file, where you would assume that, okay, there cannot be any null exceptions anymore, with unsound null safety, it can still happen, because the nulls can kind of sneak into your null safe code from your non-null safe code. And just there are, of course, we decided to go with unsound null safety. And for small projects, you can use the manual migration. But if you don't want unsound null safety and you have a larger project, you can still just run the migration tool run, apply the changes, and clean up later if you realize later that the migration tool didn't do everything exactly as you would have. It's a very fast way to do the migration. I wasn't a fan of it because it gives you a false sense of security, because you think you won't have any null errors anymore, but you might, because it's very hard to review, because it's a large code base and you let the migration tool run. So it's very hard to review thousands and thousands of lines of code. And I think the Dart migration tool have the tendency to basically introduce sometimes unnecessary null assertion operators or unnecessary late, the late keyword, or maybe you need like a more thorough refactoring to get rid of null values. And I think, yeah, but anyway, what I wanted to say that it's still, if you are migrating a bigger project, we should first consider letting just the migration tool run. Depending on your requirements, it can be a good option still. So some of the things that we learned, of course, it's a general rule of software engineering is that you want to integrate with the main branch as often as possible, because you want to enable basically continuous integration within the team. So you don't want someone working on, like, you need to think like there are multiple people working on a big branch for weeks, or then if the first one, maybe the first person can maybe merge their branch quickly, but then the second person comes and then they need to fix a bunch of merge conflicts. And then again, it's when you need to fix merge conflicts, you tend to not pay that much attention to details, and then it's very easy to introduce bugs. So that's why you want to merge as often as possible. You also don't need to migrate every dependency yourself, even if it looks like a dependency wasn't migrated. So first, what you will do when you need to update your dependencies, if you check if the dependency was already migrated. For the most popular packages, this was migrated a long time ago. So today I wouldn't worry about it that much. But for maybe you depend on some smaller packages that are not maintained, the authors of the package decided to, I don't know, write Rust or something, then they don't maintain the package anymore. In that case, it can happen that some packages are not created yet. So then what you can still do is you check your pre-releases, because for some applications, what developers do is that they release the no-safe version as pre-release. So it's not stable yet, but it's already done. And then you can check that it works good enough, if it works well for you. Then you can also ask the maintainers, because they might be already working on the no-safe version, which also happened to one of my open source packages, that someone just asked me if I already migrated, if I could migrate the package, and I just did. And before that, I just didn't have time or didn't dedicate enough time to that. So you can always, as I mentioned, check the pre-releases, ask the maintainers. If the maintainer is gone, is not writing Dart anymore, or doesn't care about the package, you can still check the pull requests to the GitHub repository or the forks, because the community might have already noticed that pain, that this package is not migrated. The maintainer is gone, but the community has already fixed and migrated the code, and they are trying to contact the maintainer with the fix, but the maintainer is gone. But you can still check those. Then you can also check the alternative packages, because if a package was not migrated in almost a year, that's never a good sign. It's not a good sign of code health or project health. So maybe it's time to change your dependencies. And as a last resort, you can just fork and migrate the dependency yourself. One more thing that I wanted to share is that only local variables can be promoted, which is at first very hard to understand. It's not intuitive, but we will take a look at this. So we have a class foo with a nullable string of a, and then we create an instance. And then, as I mentioned, I hope you remember type promotion. which means type promotion is that what you would expect is that Dart checks if it's not null, and if it's not null, then you should be able to use foo.a as a not null value. But Dart will complain that you cannot unconditionally access this value because foo.a can still be null. But why is that? Because it's not intuitive. I just checked on line 7 that foo.a is not null. Then one line later, then I suddenly cannot use I cannot use it anymore as a non-null value. It's very unintuitive. The reason for that, there is a good reason for that. You can basically in Dart subclass this, so extend foo with a strange foo class, and so even if it was a string, so even if it's so in foo it was a regular property, but now in this strange foo it will be a getter, and once it's a getter you can do all kinds of silly things like randomly returning a null value. Of course, again, this is not something like this code should never be in production, obviously, but it is technically possible, and also like there might be a valid case where you want to override it with a getter, and then you cannot really be sure that when you call it a second time, you cannot be sure that it will return the same value. So that's the reason why it will not work. So in this case, you can see how this could crash. And Dart is very pessimistic and very conservative. And Dart will tell you that, okay, even though it's a very rare thing to happen, it is allowed by Dart. So it's you can write this class, it's allowed by Dart, but then Dart will know that, okay, this can be null, even if it looks like it shouldn't. The way to fix it is to create a local variable, and then that local variable can be promoted. So now this will run without any tricks, and even if it's a very silly foo class that returns things randomly, it will now work again. There's a very good Dart docs about fixing type promotion failures. They have a lot more examples. They are even more edge cases, but like, for example, the only local variables can be promoted error. I think that everyone encounters that in the first hours of development, and then it's you stay there scratching your head and you don't understand why is that. Another rule, this is like a very subjective rule or advice from me, that you should prefer type promotions over the null assertion operator. So again, just let's take a look at this example. We have foo class with a and b properties. They are both nullable strings. And then you want to do something with a, but only if it's not null. So what you do is you check the foo.a, and if it's not null, and if it's not null, you do something with it. In this case, I only want to print it. What you can do is use the null assertion operator, which is the exclamation mark, the bang exclamation mark postfix operator. But I really don't like, so it will be good enough for Dart, and Dart will. So when you use the null assertion operator, you are telling Dart that, okay, get out of my way, let me run this code, because I know it won't be null. So it will be valid. Dart will let you run this code, but I don't like this approach because it makes, so you're basically repeating code. So foo.a, and it's very easy when you update this. It's very easy to basically miss this detail that, let's say, the requirements change and I need to change from A to B, but I'm in a hurry, and I only updated this. I only update line 12, but I forget to update it in line 11. But in this case, as I'm saying that I'm using the null assertion operator, I'm telling Dart's type system to let me run this code. Like, get out of the way, let me run this code. And Dart will not prevent you from running this, but you in fact did not check correctly that B is not null, because you repeat code, it's in 2 different places, and it's very easy to miss the check. And if you add a null assertion operator, you basically silence this error. So what I instead prefer to do is to create a local variable. It's a line longer, but it is safe. So now if you need to change anything, you can basically fix it in one place, and you can be sure that things will continue running. I have a couple of more slides. If no one interrupts me now, I will continue. It should be like 5 minutes. But okay, so we had Mocktail. We used Mockito before for our unit tests. But we have taken a look at the null migration, null safety guide on the Mockito package, and it was, I don't know, we just realized, oh, this is much more painful than we want it to be. And we already knew about Mocktail, and then we decided to just replace Mockito with Mocktail, because the Mocktail API, null-safe API is just so much more, I don't know, similar to Mockito's original version, and it was really a breeze. It was very easy to migrate from Mockito to Mocktail, and yeah. And one thing I wanted to mention is that imperfect code will stand out much more with null safety. Because let's say, for example, null was not handled previously. Now you need to decide what you do with this code. And so, of course, you can use the null assertion operator on the basis of, okay, if it worked before, probably it will continue to work for a couple of, for a bit more. You can argue that it doesn't make things much worse. But obviously, as I mentioned, I'm not a big fan of the null assertion operator, as it silences real legitimate errors, or basically design issues with your code. You can also then, if, as I mentioned, the imperfect code will stand out more, and then you need to think, okay, how you fix it. Do you return null if the null was not handled previously? Should you throw? If you throw, then you need to decide what and when you throw. You also need to make sure that you catch these exceptions, because in Dart you don't have checked exceptions. So if you willy-nilly decide to throw things in one part of the code, there's no guarantee that anyone will catch that error. You can also use the either class from the Dart C package. It basically means that this class is a wrapper for either a value or an error, most often. I mean, it could be any other 2 classes, but it's most often used as a like a container of either a value or an error. Or, as I mentioned, you can take a better look and think, why was null not handled? How should I handle it? Can I basically make sure that the null values are affecting as little of the code as possible? One more example that I wanted to say is that you should work smarter, not harder. So we use GraphQL, and we want to introduce Artemis, which is a code generator for GraphQL and Dart. And we really want to, so it was not that important before, but with null safety, I believe it's going to improve things so much. And what happens without null safety and Dart and GraphQL is that the null safety information is sprinkled around so many different places of your architecture, basically, because on the server side, the server knows that something can be null or not. Then you also have your queries and mutations where you ask for data. But maybe the value is not nullable, but in your query, you don't ask for it. Then if you don't keep the data models in sync with your query and your server, then so it's just, it's a nightmare to maintain these things and keep all these 3 things in sync over time. Just think about if the server maybe makes something non-nullable, but you don't realize that, then you will have to deal with that nullability all the way through, and it just makes your code harder to read. What can also happen is that when you write your data models, you check your server and you see that something is not nullable, but actually in your queries, you don't ask for that value, then obviously that value will not be there. So it's just a nightmare that you like maintaining these 3 places in regards to nullability is very, very hard. And then Artemis can help you with that. It lets you basically write your queries and mutations. It will take the schema definition file from your server, which can be automatically generated. And based on these two, it spits out the correct data models for you, and everything will be basically almost guaranteed to be in sync. And that's a huge win, because instead of maintaining and paying attention to these 3 places, you can just write your queries and your data models or your data classes will be automatically generated, and the data will be correct as it takes care of server nullability values. And that is something that I'm really looking forward to introducing. Then, thank you everyone for listening. As I mentioned already, I'm working on a podcast. I have a couple of episodes with very knowledgeable people. It's a great honor to be able to talk to them, and I'm really glad that I can share these episodes with you. I had a little of a longer break, but I'm looking forward to releasing new episodes again. And if you have any questions, please let me know. And yeah, welcome everyone.
So thank you. So null safety is so important in Dart nowadays. So as you shown, we can migrate our application partially, not full migration for short PRs and less risky like code. So at the beginning, developers stayed a bit aware from null safety migration, but now we can see that most of the packages supports null safety, and it's a requirement for the packages to be selected as Flutter favorites. So it's so important to use null safety in Dart, and especially in your Flutter applications. I think we don't have any questions. Cagatay is muted. Okay, could you?
Yes. In every single online meeting, I have this moment. Every single online meeting, I'm muted. But anyway, yeah, I'm really wondering the statistics about how many projects, like Flutter projects, have this null safety not enabled, not used. Because I'm thinking about the time that there was no null safety. It's really like wildlife. I don't know how we survived on those times. When I migrated to null safety, I found so many bugs actually while migrating.
Yeah, it's very easy to overlook something, and yeah, I don't know, it's a lifesaver, and I think that's one of the things that I wanted to mention as well. That's why I really like the Dart language. I worked with a lot of different languages, so Python, JavaScript, TypeScript, and many more, and I really enjoy working with Dart. And I think the null safety was like one of the last things that I really missed from other languages. Of course, the next thing that I still miss is like the painful code generation for JSON serializing. That's again, I think that's a really good thing that the Dart team is already working on it, and hopefully that pain will go away soon.
I think I will be completely happy. I will be complete when data classes are in place.
Yeah, I think that's one of the most important things that are still not part of the Dart language.
I have this freeze class, Remy's class, but sorry, not freeze package. But code generation in the end, it's very useful, but it's code generation in the end.
Yeah, it shouldn't be that hard to serialize a JSON map.
But Freezed is so helpful now.
Yeah, of
so
course. Yeah.
Yes.
Also, the Flutter team advises to if your code is bigger and also your classes is bigger, it advises to generate it, not make it manually.
But also, like with this freeze, it also helps with unit tests. You can easily copy with write this your mock data. But at the same time, like when you are updating your packages, because we have release cycles, right? And every cycle we update the dependency versions, and like there is this code generation build runner that is like there are so many packages that depends on it. We are trying to eliminate this. We made a mistake in the beginning. We had more packages, like we have, I think, Dio, internet connection package, which we want to remove soon. And then
can I ask about that later? Why do you want to get rid of it? And
Dio, you mean?
Yeah.
Bugs, because there are bugs that I don't know. Like it's we don't feel like we have full control what is going on. There are so many issues, like in interceptors. When they introduced this Dart Null-Safety, actually we didn't actually update our packages until we had to do Dart Null-Safety migration. And when we started this migration, we had to upgrade all the versions. And then we realized that so many things changed in this Dio package. And then I was, okay, it was a mistake, I admit. Then we started to continuously upgrade all the packages, bump the versions. But in the end, these like, when there is a issue with backend, our backend team completely says, hey, you have this many requests. Like when there is extra request, then there is always this usual suspect that this package might do it. So especially, it's third-party dependency, because I couldn't find out what is the reason. So
And you want to use HTTP, the HTTP package, or what you want to
replace it with? I think that is, I'm not really aware of what is there out there, but I want to go with what is Flutter giving. Do you know? Do you have any suggestion?
So I think the HTTP package is the best option. That it's a bit more bare bones, but it's probably it's more stable, and it's
You know why we use Dio? Because we are coming from Android. We started this project with an Android development, and we use retrofits a lot in Android development. And now there is this retrofit package with Flutter, and then it works well with Dio. So that's why like it was Dio plus retrofit.
Yeah, I also worked with Dio and retrofit, and that, I mean, it's really nice, because you can basically just declare your models or your how the response is created. You just pass the URL paths, and I think yes, that's one of the big points for Dio, the retrofit package. I think it's really amazing.
Yeah, actually, I'm just checking the page of GitHub page of Dio, 65 open issues, not that bad. So it's like, that means that because they closed around 1,178 issues, that means that they are actively taking care of this package. It has been there for a long time, actually.
I think it was some time that it was not so active, but the last time I checked, the maintainer is back and like improving things significantly.
Yeah.
So
we came to hear from code generation, but in the end, yeah.
Sorry, I interrupted you with the question, but
two-sided thing. It's good and it's bad.
Sorry.
I interrupted you. You were saying something, Vince.
I was just thinking about, like, of course, like, what's the solution for a third-party package? Is to add a new one. And I was thinking about writing something similar, but then that's why I wanted to learn a bit more why you why you are thinking about replacing the Dio, and what were your pain points?
Yeah. It is usually about this number one suspicious, like if things go bad with the backend, so you don't know what is going on there. You need to actively check if there is a new issue. And yeah, so if you know something that is not really if you have something that you have more control over, for example, we have these interceptors, and like the current way of dealing with interceptors, I don't know, it's not really easy to read or what's going on.
Okay. Yeah.
So it's a good discussion. We are continuing our stream, and
Yeah, true.
yes. So it's an interesting to know that Dio is not. It's stable, but we can't find another packages that are more stable. Like I think HTTP. I've never used Dio. I started with HTTP and now I'm using HTTP. It's good. Uh, yes, you can know the source of the error and you can fix it easily. Also, you can interact with your backend. So, if you have something to say, or
Nothing special, but I'm personally trying to reduce in my projects one code generation, other like minimum number of dependencies. So like I learned it in a hard way when I migrated my project to Null-Safety because I had to deal with it.
so thank you, Chatai, and
Thank you very much. It was a big
you
pleasure.
for introducing your presentations in Flutter Tunisia's meetup. You are always welcome if you have any topics to introduce, and also if you have anything to announce, like the Flutter Viking. It's coming in the 2nd and the 3rd of February. It's fully online due to the pandemic, I think. So I will join it, and I hope I can see you completing this topic in the Flutter Viking conference. Also, Vinci, I'm watching you. We are active on Twitter, and all the Flutter community is there posting tweets and discussing all the topics with 100% transparency. So all is transparent. We are discussing topics with the Flutter team, with the Flutter developers, with the company owners, with the packages maintainers. It's really helpful for all the beginners, for the junior developers, and for the senior developers to make an impact in the community and develop new things that helps everyone to go faster and simpler, like you say. So thank you, everyone. And look, so Vinci, you want to
Yeah,
say
just wanted to say thank you for organizing. I know it's a ton of work, and
Yeah.
I'm really glad that the only thing that I had to do is join the streaming. So I'm really helpful. I'm really grateful for your work and for creating this event.
So when is the next podcast, Vinci?
If I
Mhm.
yeah, let's see, Friday. I might have a short episode.
Okay, great.
And also, I really like your talk. I'm sure I need to listen to it again, because it's like not that part of Flutter that you always use.
Yeah.
Because usually your like regular developers are in the layers above that. But that's a topic that it's been a long time that I really wanted to understand things well, and I will re-listen your talk.
Thank you very much. Yeah, because it was heavy. We had limited time. It was hard to follow, I'm sure. But read also the draft article.
Yeah, I will. Yeah.
Okay, see you then. Have a nice evening. Bye-bye.
Thank you, everyone. Have a great.
Thank you. Yeah.
Thank you.
See you.
Bye-bye.